Hi again. Okay, we are going to graph cosecant function. So what we need to start with, let me pull up your notes so I can make sure I follow the steps that match the notes that I have stated for you guys to make it as little confusing as possible. So we want to go ahead and start, and we're going to replace the cosecant with a sine. So the opposite, the reciprocal of cosecant is sine. So let's just go ahead and graph this guy, which we've done a little bit by now. So hopefully we're a little more comfortable with this. Okay, step 2 says we want to identify the amplitude, the period, and the phase shift. So this is my amplitude. My period is with this guy, right? So your period is 360 divided by 1. So it's going to be 360 or 2 pi, whichever one you want. Okay, and then your phase shifts, it's a 1x, so we can just say this guy is, again, right, because it's a negative, pi over 2. Remember, technically, we're supposed to be setting this guy equal to 0, especially if that constant with the coefficient with the x is not 1. So if we do set it equal to 0, we get pi over 2, which is great. And then what does this plus 1 do? That means we're going up 1, okay? So this is how I usually write it out, is just take the function and write underneath them and whatever. But let me just write it out kind of how we have been, because it's a little bit easier for you guys to see. The period is 360 degrees. And then remember something important. We always divide our period by 4. So 360 divided by 4 is 90 degrees, or pi over 2. Okay, so that's a good thing for us to know. And then we got these shifts. So we have right, pi over 2, or 90 degrees, and we have up 1. Okay? So, just like we did before, I'm going to graph a sine. Okay? Just the regular sine with your amp and your period. So in this case, sorry, I don't have my paper ready for you guys. Okay, so let's go ahead and graph. Let's graph it in yellow. We're going to graph, that was a very hard decision for me for some reason, sine x. Is that okay? So looking at all of the pieces that we have, well, let's do sine. So we know sine starts at the origin. It's a positive function, so we're going to go up, okay? So we're starting here. We're ending at our period, which is 2 pi. So we have the start, we have the end. We need the middle, which is also at the center line. And then we need to do half of this. So half of pi is half. Oh, look at that, half pi. It's a positive, and then our amplitude is 3/2, so our amplitude is really equal to 1.5. So 1.5, halfway through, 1.5. Okay, so that is that function. Now let's shift this function. So now I'm going to add in my left, right, up, downs. Okay, so we had right pi over 2. Pi over 2 is 90 degrees. Which, remember, these guys are really pi over 6s, so 30 degrees. So this is 3 units. And your graph paper might be different. If you want to stay consistent and use this one, feel free to print it off. The link is on the top of the paper here, or at the top of the lesson. And then we need to go up 1 unit. So we're going up 1 unit, we're going right 3 units, okay? So each of my yellow points, we need to move these guys. So we're taking this guy and we're going to go right 3 units. 1, 2, 3, and we're going up 1 unit. So we're going to be right here. Okay, cross it off. right? 1, 2, 3, and we're going to go up 1 unit from 1.5, so we're going to be up here at 2.5. Cross it off, 1, 2, 3, up 1 unit. Cross it off, up, or right, 1, 2, 3, and then up 1 unit, so it'll be down there. Right, 1, 2, 3, and up 1 unit. Okay. All right. So for secants and cosecants, it's very helpful if you guys extend your graph more than one cycle. Okay. So we have something important happening every 90 degrees or every 3 units. And then let's just continue. So we have center, high, center, low, center, 1, 2, 3, high. We're going up 1.5. 1, 2, 3, center. Yeah, we covered enough. 1, 2, 3, low. And if you guys wanted to, you could draw a dashed line here because this is like your new x-axis. Sometimes that's helpful for kids, okay? And then there's also some who like to do the y-axis here too. So then if you can kind of see like this is my new x, this is my new y-axis, okay? It's up to you. I'm actually gonna make those solid. You don't have to by any means. Okay, so let's see, we got that. All right, let's do a little bit on this side here too, just so you guys can get the full effect of what this graph really looks like. 1, 2, 3. Okay, so I think we should be good. Okay, so we did all that. So we now are on step 2. We need to find the asymptotes. These are the shifts or the dashed lines that go through the center. So all of our center high, center low, center high, center low. So we need to draw these dashed lines that are horizontal or asymptotes. So I'm gonna draw. Let's do it in this green color. So we're just drawing a dashed line, drawing a dashed line, drawing a dashed line through all of our center points. Okay, and then it also says to graph the sine function as a dashed line. So we're going to take this and graph our sine function as a dashed line because it's not really there. We're using it as an aid to help us find our cosecant function. Okay. So there it is. We have asymptotes, dashed lines. We have a dashed sine graph, and it is doing all the shifts. So now we're going to go ahead and graph the cosecant, okay? At all of our high and low points, this is going to be where we're going to draw our parabola-looking shapes. They are not parabolas by any means, but they're just U's, okay? So it doesn't matter the steepness of these. You just need to get it close to the asymptote, touching or going through your high or low point, and then getting close to your asymptote again. Arrows because it's a continuous function. Dun, dun, dun. These lines are never going to cross any of the dashed lines, so that will help us. If we drew it this way, it's on the dashed line. That doesn't make sense. So this is what a cosecant graph looks like. Now, how cool is that you learned how to graph something that looks like that? Tell yourself in Algebra 1 that you'd be graphing that stuff. You'd be like, nope. But you did it. So good job, guys. And I think that is it for this one. We'll see you next time.